Good morning everyone. My name is Radhika Basavaraj Daddi. I am studying in KLEIT Institution of Technology Hubli in Computer Science branch, and now I have done the project on eye disease detection. Here, first block of code, it shows that we have to mount our Google Colab with the drive so that we can access the files from the drive. And next, we have to import the Kaggle files, so that we have used this block of codes. Here, in this we have downloaded the dataset of eye disease with using Kaggle, and we have unzipped all the contents of the dataset. Now we have to import the required libraries. Here we have imported matplotlib. It is used for the visualization, and cboard is also used for visualization. And we have imported torque. It is used for building and training the neural networks. Like this, we have to import number of libraries. Next, we have to load our data. So that we have defined the function called load data. It is used to load and transform the dataset using the image folder and torque vision. Here we have resized all the images in the dataset to 256 into 256 pixels, so that all the images are of same size and we can access them easily. Here, load data function, it is used to load the dataset. Here we can see that the dataset contains 4217 images. All are of the size 256 into 256 pixels. And here this block of code is used to determine the number of classes in the dataset. So there are totally four classes in the dataset. That are the four classes of diseases: cataract, diabetic glaucoma, and diabetic and normal. There are four types of diseases in the class, and here it shows that there are four types of the diseases. Here this function is used to display the image along with its label. Here we can see we are displaying the first image of the dataset, and this is the image that it is showing the cataract. This is the first disease of the dataset, and it is of the size 250 into 250 pixel. And now we are splitting the data into train data and test data. So here we are using the function train test split. It splits the dataset into training and testing sets. And here we are calculating the number of samples for the training set and number of samples for the testing set, and returning the train data set and test data set. Here we are creating the data loader for both training and testing data sets. The function show batch is used to display the batch of images. Here it takes the parameter as data loader, and it prints all the batch of images. Here we can see the batch of images. Now we are using the convolutional neural network for image classification. Here we use Lee-ReLU for activation and batch norm for normalization and activation. Here we use the model to initialize the model with the specified number of output classes. There are totally 4 classes in the data set. And here we are defined a function batchgd, which performs the gradient descent to train a neural network model. Here we are calculating the training and testing losses at each epoch. Here this block of code trains the model for 10 epochs and saves the training and testing losses. And here we are plotting the training and testing losses of the data over epochs. Here we can see this shows the drain loss and this shows the test loss. We are plotting the confusion matrix and heat map for the data set. Now we can calculate the accuracy of the model. Here we can see that the accuracy of the model is 83.89% and precision of the model is 83.89%, and we are calculating all the precisions. Now we can run our Here we are using the Streamlit app to give the access of the model to the users, so that we are executing block of codes. Here we get the URL to go to the interface. Here we have got the interface for the users. They can browse the files, they can upload the images of the disease and it predicts the image as cataract. We can see here the users has to upload the images and it predicts the disease of the image. So the applications of the model are, we can predict the disease early, and it is very useful for the users to early predictions and use. Thank you.